Water on Earth that is in rivers, lakes, and the oceans is easy for scientists to see and measure. But what about the water that is inside the dirt under our feet, or at the root of all the crops grown on the planet? It's not so easy to see, but we all know it's there. Thanks to a new NASA spacecraft called SMAP, researchers hope to find out much more about the water inside the dirt and try to figure out why it stays in some places and leaves others. SMAP is short for Soil Moisture Active Passive, a name which refers to the set of instruments the spacecraft will use to decipher the layers of water just beneath the surface. It's information that could lead to better forecasts of growing conditions, floods, and droughts.
The amount of water the Earth holds is constant, but some areas may receive more water, some areas may receive less water. SMAP will help us improve our ability to forecast where those regions are and to perhaps take action to mitigate the effects of either too much water or too little water.
Using a 20-foot diameter antenna, the SMAP observatory will take detailed readings of the moisture in the first 2 inches of topsoil around the world in such detail that scientists can establish global patterns for how the moisture evaporates and how it affects weather conditions. Engineers have tested the spacecraft, fueled it, and folded up its antenna and solar panels to fit inside the nose cone of the Delta II for launch.
This mission has been very smooth so far. The preparation of the rocket and the preparation of the satellite has gone very smoothly. There's been very, very little issues with the activity so far.
3, 2, main engine start, 1, 0, and liftoff of the Delta II with the NPP satellite.
The Delta II, built and launched by United Launch Alliance, has earned a reputation for launching dozens of NASA missions to observe elements of the Earth in detail, plus extend NASA's research reach out into the solar system.
There's been 152 launches of the Delta II since 1989. 51 of those have been for NASA, all successes. It's been a great rocket. We sent 2 Mars rovers on Delta II back in 2003, Spirit and Opportunity. And every time you see a rover on Mars, it's hard not to think of the Delta II heritage. Delta II has done it all for NASA.
SMAP is launching from California so it can be placed in a polar orbit, meaning its path over Earth will take it near or over the North Pole and South Pole on each pass around the planet. That way, the observatory will see and measure the entire surface of the world to produce the most accurate picture possible of moisture patterns in the dirt. Once in space and flying free of the rocket, SMAP must unfold the 3 solar panels that will provide electrical power to the spacecraft. Then the long boom with the all-important antenna on it has to unfold correctly. Finally, the antenna itself must open to the proper tension so it can correctly steer the radar signals for the SMAP instruments to perform their own intricate studies. It will take days for the process to play out in orbit, while controllers stand watch in ground stations. The work is worth the wait for scientists who say understanding more about the moisture in the 2 inches of soil around the Earth is vital to completing our understanding of our whole planet.
One of the most important applications is improving our ability to predict weather and climate. The soil moisture conditions at the surface are important for initializing weather models that predict future rain and temperature. The soil moisture is also very important in improving climate models that can help us forecast longer range conditions of drought and conditions of atmospheric temperature and precipitation in seasons to come.